All right, so we're going to talk about chapter 6, discussing chapter 6 of association rules, and we're covering association rules in two parts or in 2 weeks. So this is the first week, and the first week will continue, or it will be about the basic concepts of association rules. We're going to talk about frequent item set mining methods and that we use to okay, and we're also going to talk about association rules from frequent item sets, and we're going to learn about all of these concepts and ideas and algorithms, and it's very easy topic to cover, and I'm sure that you're going to enjoy it as we speak. Now, let's talk a bit about frequent patterns. The first week when we started talking about data mining, we said that one of the data mining strengths is that it allows us to discover hidden pattern, and this is where we this is what we're discussing this week is actually an excellent example of how to use data mining techniques to uncover hidden patterns. Now, when we talk about hidden patterns or frequent patterns, we are actually talking about item sets, we are talking about subsequences, and we're also talking about substructures. Now, item sets, it means that when we are having items that exist together at the same time. Okay, so a set of items can appear together frequently, such as customers in a supermarket buying two items together all the time, such as the toothbrush and toothpaste, such as the loofah and the soap, or as here mentioned, such as milk and bread. So it's saying that these are items that are frequently appearing together, and you will see that all of the examples that we are dealing with today are about things that people buy together from the supermarket, and this is what happens, or this is the most famous application of association rules, which is called the supermarket basket problem. Now, when we talk about subsequences, we're talking about items that happening in sequence. So when we say that frequent patterns are item sets or subsequences meaning that they happen in sequence. So something happens and after a while something else happens. For instance, someone would go and buy a laptop, and then after some time, after let's say a few weeks, they will come and buy a suitcase for the laptop or a screen protector, or so these things that happen after some time. Substructures, we're talking about the fact that that can include item sets and subsequences. So it can have the both kind of patterns, but all of the examples that we will have in this week are about only item sets, nothing about subsequences or substructures. Now, the questions that we try to answer when we are using association rules or we are mining frequent patterns is we want to know how to mine these patterns and rules efficiently from a large data set. So we want to not only discover these patterns and find out about association rules, we also want to do that effectively. And when we say effectively, meaning that we don't want it to be expensive, computationally expensive. It does not take a lot of computational time in order to be produced. Also, also, we want to identify how to use such patterns for classification, for clustering, and also other applications. So association rules are used in other applications such as classification and clustering. And the relationship between the frequent patterns and association rules is that once we create or once we identify frequent patterns, it is very easy for us to define association rules. So what is association rules? An association rule is a pattern that states when an event occurs and another event occurs with certain probability. So when we want to say, when we define an association rule, we're actually saying that based on a certain probability that this thing, if this event happen, another event will happen. If the customer buys bread, they will buy milk. So this is what we're talking about in terms of association rule. But we also have to mention how the probability of that happening. What is the probability of that when someone buys bread, they will be buying milk? So association rules are also an if-then statements, and they help us discover the relationships between unrelated data. So there is no logical relationship between bread and milk. Okay, there is also a very famous example that they found an association between buying diapers and beer. Although both are not related, but it was uncovered through data that these are actually can be associated with an association rule. So it means that usually these objects are not related, but we have evidence from data that they are frequently used or bought together. Association rules, they found all set of items, which is in this case the item sets, that have support greater than the minimum support. And we're going to identify what support is. But you need to know that for an association rule, when you are defining an association rule, you are actually setting, or you are supposed to be setting a minimum number. This number is called support, and support means that how much support of this rule do you have from the data set? How sure are you, based on the data set that you have, that this rule is correct? So you will have to have a minimum support. You have to have a threshold. You cannot just accept all association rules. Then using the large item sets to generate the desired rules that have confidence greater than the minimum confidence. So now, once you identify all the item sets that have a support that is more than your minimum support, you will be using the large item sets to generate rules that you are confident about more than your minimum confidence. So this means that for an association rule, you will have to have a minimum support and a minimum confidence. Now, this is actually this application of an association rule and how to use the minimum support and the minimum confidence will be very clear towards the end of the lecture, because we will have an ongoing example until we reach a point when we identify association rules, define or find item sets which are greater than the minimum support, and define association rules that are greater than the minimum confidence. And as I said, a very widely used example for association rule is the market basket analysis. So what is market basket analysis? It's actually the process of analyzing customer buying behavior. So you would go to you would go to your transactions data set, and you will see what are the items that are bought by each customer. So each customer will have their shopping basket, and you will be identifying the items in their baskets in order to find the different items that they place in it. And based on that, you will be discovering association rules about what items are frequently bought together. Now, this discovery will help the retailers in marketing these items, so that you will know that this customer would be thinking of buying such an item if they already bought another item based on your previous analysis. So it's more like when you place an order in Amazon and or click on details of an item in Amazon, and then you will see that towards the mid of the page, you will see some items suggested as items frequently bought together, or they will say other customers frequently buy this along with what you've selected. So this is actually based on their existing data of customer behavior, and it will allow them to market more items for you to buy. So you, as the market analyst or data mining specialist, you would look at the shopping baskets by different customers and their content, and you will want to answer the question of which items are frequently purchased together by customers, looking at all the customer shopping baskets. Now, once you, or in order to identify these this information, you are supposed to define association rules. So for example, if the customer buys milk, then he may also buy cereal, because it makes sense. If you are buying cereal, you will need milk. If a customer buys a tablet computer, they will be buying a case cover. Okay, now in order to analyze these association rules, because you will have so many association rules based on the data that you have, but you need to identify two basic criteria that will allow you to identify the relationships between buying different items together. So there are two basic criteria for association rule use: support and confidence. And we're going to learn about what does a support mean and how is it calculated, what is confidence and how is calculated. Now, to identify the relationships and rules generated by analyzing data for frequently used if-then patterns. So in order to identify the relationships and rules that are generated by our if-then patterns, we need to identify the support and confidence. And usually, as we just mentioned, an association rule needs to satisfy our user specified, we specify, or in case of the question in an exam, you will have a minimum support and a minimum confidence specified. According to these minimum support and minimum confidence, you need to generate association rules. Now, to calculate association rules, as I said, you need to know the support and you need to know the confidence for each rule. The support of a rule is the frequency of occurrence. So if we have a rule, it's with X exists, then Y exists. In this case, if we want to calculate support, this is actually the frequency of X and Y happening together divided by N, which is the total number of transactions. And the confidence is actually the frequency of X and Y, okay, happening together divided by the frequency of X. Now, support also can be defined using the union and probability. So the support of A implying B, meaning that A and B occurring together, is the probability of A union B together. And the confidence of A implying B, it's the probability of having B, okay, and not A. Okay. Now, another way to calculate the confidence is confidence of A and B is the probability of B and not A, and in this case it can be calculated by support of A union B divided by support of A. Now you will see that all of these rules can be very simply applied when we are talking in examples. So support count of A union B divided by support count of A, and we are going to use this when we generate the association rules. But first we need to identify, or we need to learn how to identify the frequent item sets, and this is what we're going to define in the following slides. Now, if we have a set of all items in the store in I, which is I1, I2, I3, which stands of item until IM, where M is the number of items in a store. Now, the set of all transactions is usually given in a transaction database. So you'll have transaction 1, transaction 2 until transaction N, and each transaction will contain a number of items. Okay. Now, each, as I said, each transaction is a set of items that they belong to the list I. Okay. And each transaction has a transaction ID, which is TID. So you will have the set of all items in the store: bread, milk, cereal, etc. Okay, and then you'll have transactions which contains, or which consists of number of the items. Okay, and these transactions are part of a transaction database, and each transaction will have its own ID. Okay. Now, if we have, these are different baskets. So this is customer 1 bought A, B, and C. Customer 2 bought A, C, D. 3 bought B, C, D. 4 bought A, D, E. 5 bought B, C, E. Now, if we have a rule that we're saying that A implying D, meaning that A and if there is A, we will have D. Now, the support of this rule would be, first of all, the support will be about the whole transaction that we have. So we have here 5 transactions. Now, how many times do we have A occurring along with D out of the 5 transactions? So here we have A alone, so we're not counting this. Here we have A and D. Here we don't have A, and here we have A and D. So we have it twice. So we say that 2 out of the 5 transactions are supporting these rules, that A exists, then D exists. Now, what is our confidence about this rule? We want to see the transactions where A occurred, okay, and D occurred. Now let's see the transactions where A and D occurred. We already said that there are 2, 1 and 2. Now, what are the transactions where A occurred, which is A, 1, 2, and 3. So A happened 3 times. 2 of them D was there. So the confidence is 2 out of 3. Let's see about the second example, which is C and A. Now we want to see the times where C and A were found together. So here A and C, here 1. A and C, here 2. Do we have A and C here? No. A and C here? No. A and C in here? No. So it happens 2 out of the 5 transactions that A and C happened together. Okay. Now let's see the confidence. How many times do we have C? A and C happened twice, so it's still the same. How many times do we have C? 1, 2, 3, and 4. So 2 out of the 4, this is our confidence. Let's see this rule, which is B and C implying D. Now, B and C, let's see how many times happening. B and C, 1, okay, 2, and 3, okay. Now, this is only this side. We want to see when do we have B and C and D. B and C and D, no, here, no. B and C and D, here, here, no, here, no. So it happened once out of the 5 times. This is our support. Now, let's see the confidence. How many times do we have B and C? 1, 2, and 3. And only one of them we have B, C, and D here. So our confidence is 1 out of 3. Okay. Now, this is continuing the same example or the same route about association rules, and this is our transaction data sets, and this is the transaction IDs, and these are the item bought. So we have item bought about in each transaction ID, okay, and we want to find out the rules that X happens implying Y with minimum support and confidence. So we will have a minimum support setup and a minimum confidence setup. Minimum support is the probability that a transaction contains X and Y. And confidence, it's conditional probability that a transaction having X also containing Y. And we just explained how we calculate support and confidence. So the question will be giving you the minimum support. In this case, it's 50%, and the minimum confidence is 50%. Now, looking at the frequencies, you'll see that beer happened 3 times, so we have beer 1, 2, 3 in each transaction. Nuts happened 3 times, 1, 2, 3. Diapers happened 4 times, 1, 2, 3, and 4. Eggs happened 3 times, so here 1, 2, and 3. And beer and diaper, okay, beer and diaper happened together, 1, 2, 3, 4, 1, 2, okay, 1, 2, and 3. They happened 3 times. Now, these are the frequent patterns. Now, notice that we did not identify milk because milk happened only 2 out of 5. Now, 2 out of 5 is actually 2 out of 5 is actually less than 50%. 2 out of 5 is 4%, 40%. Okay, so we identified only the frequent patterns which are more than the minimum support, which is 50%. So the frequent patterns, we use the minimum support. Now, when we want to identify the association rules, we will be identifying, first of all, we will be identifying them from within these frequent patterns. We're not going to come up with new ones. We will use only these frequent patterns, and we will identify all the rules that are satisfying the minimum confidence. And in this case, they found that beer and diaper happening together, we have the support is 60% and the confidence is 100%. In this case, we accept this as a rule because it is satisfying the minimum confidence. And we also have the diaper and beer. In this case, we already identified minimum support was 60% and diaper is actually 75%. So these are the only rules. We have many rules, but these are the only rules that we're going to use because they satisfy the minimum confidence. Now let's see why are those different? Why beer and diaper will have 100% confidence while diaper implying beer is actually having only 70%. Now, first of all, let's calculate the support of beer and diaper happening together. So beer and diaper, 1, 2, and 3 out of 5, and 3 out of 5 is actually 60%, so this is the support. Makes sense. Now, beer and diaper together, okay? So first we will be identifying these beer and diaper. These are the 3 of them, okay? And how many times did beer happen? 1, 2, 3. Now, notice that beer and diaper happening together is 3 over how many times beer happening together? 1, 2, 3. So it's 3 out of 3, and that is 100%. Now let's look at the way around, the other way around, which is diaper implying beer. Now, diaper implying beer, the support we already calculated, 3 out of 5, which is 60%. Now let's see diaper happening together with beer. That is 3. 1, 2, 3. Okay, but how many times do we see diaper? We see diaper 4 times. 1, 2, 3, and 4. So the confidence is actually 3 out of 4, which is 75%. Now, one of the very widely used algorithms to uncover frequent item sets and then identify association rules is the a priori algorithm, and it is used to mine frequent item sets from a transactional database for Boolean association rules, which means that it will give you true or false output. Now, a subset of a frequent item set must also be a frequent item set. So if we want, the a priori algorithm is actually focusing on properly identifying item sets in an effective manner, which means that we want to reduce the computational time. We don't want to continue uncovering rules and find out that they are not useful. So when in the process of identifying item sets, we can on identifying frequent item sets, which means that they happen multiple times, we have to make sure that the subsets that make the frequent item sets are also frequent. For example, this is a frequent item set, which is which is I1 and I2. Okay, according to a priori algorithm, I1 should be a frequent item set, and I2 should also be a frequent item set. And how do we say that an item set is frequent? We say that an item set is frequent when it is above the minimum support threshold. Okay. Now, after when we identify item sets, and we do that using an iterative approach, which means that we will be identifying loops. Okay. Once we identify frequent item sets, we will be using these frequent item sets to generate association rules. Now, the algorithm is actually uses a level-wise search. It's actually a nested loop that looks into a k item set, and it's used to explore k plus item set. So it's actually, when it is working with a certain item set, k, it will be looking at all the other item sets coming after k, which is k plus 1 item sets. And in this algorithm, frequent subsets are extended 1 item at a time. So we first identify what we call a candidate item set, and then we will identify which of the candidate item sets are frequent. Okay, so they are tested against the data, and we will be identifying frequent item sets of the data set. And after identifying frequent item sets, then we use them to identify association rules. Now, we said that the main concept or the main advantage of a priori algorithm is that it is identifying a frequent item set based on its content. So all of its items need to be frequent. If not all of its items are frequent, then the item set is not considered frequent. Therefore, the algorithm, when it identifies items that are not frequent, it can remove them, or in another word, it is called prune them. They are pruned. So all infrequent item set can be pruned if it has an infrequent subset. So if part of an item set was found to be infrequent, then that will be pruned. So we will not be even looking at it. And this will clarify itself very well in the example when we look into it. Now, before we move on, I will stop here for the first hour, but I need you to answer this question. So we have this example here. This is an example of transactions. So we have 4 transactions, and each transaction had some item bought, and we identified A implying C. So I want you to calculate the support for this rule and the confidence for this rule. All right, so I'll give you 5 minutes, calculate it, and then we will come back after the break to continue the second part of the lecture.